Good afternoon, everyone. Myself, Satvik, studying in GM University C section. So today we are doing an deep learning assignment on implementing and comparing the performance of CNN and versus LSTM for sequence-based dataset. So we are guided by Chaitra ma'am, and our team members are Gauss, Sanket, Gagan, and Lokesh. Next. So before coming into the introduction, so in this we first focus on the sentimental analysis, which identifies the opinion and emotional for the text, which applies from the IMDb movie and reviews. Then we take the sequence based model, which are efficient for text data and commonly used for NLP tasks. Then we primarily take the goal to compare the performance of CNN and LSTM on IMDb rating of sentimental classification. Next slide. So objectives, so our assignment is to build a sentimental classification model with CNN and LSTM. Then we evaluate the accuracy, precision, and recall and F1 score by seeing what is the accurate result. Then we analyze the model efficiently for text sequence. Then at last we optimize the model via for hyperparameter tuning. Next. Then and data collection and pre-processing. Here we take the data of IMDb movie review like 50,000 labeled review. Then the process involves loading the data with TensorFlow and Keras dataset. Then we tokenizing and pattern the sequence for the uniform length. Then we convert the text to numerical vectors. Then we split the data into training and testing. So tools which we used in this is Python, Keras, NumPy, and Pandas. Next slide. Then in this we outline the architecture of CNN model for sentimental analysis, where first the embedding layer takes place, then the convolutional layer takes, then max pooling and the dense output. The key factors are we capture the local pattern and n-grams, then fast training and less complexity, and activation we use the sigmoids for the binary output, and loss function is binary cross entropy. Next.
LSTM model for sentimental classification. So here we used an LSTM model for classifying sentiments. Then, then the architecture goes like this: embedding layer, then an LSTM layer, followed by a dense layer, and finally the output. Then LSTM is great because it captures long-term patterns in text and work better than CNN for sequential data like sentences. It uses a TAN and sigmoid activation, the Adam optimizer, and the binary cross entropy loss function. Next slide. Model evolution. So here, to check how well the model performs, we used matrices like accuracy, precision, recall, F1 score, and a confusion matrix. We tested both models on the same dataset and then compared the results visually using charts and tables. Next.
Now I am going to explain the hyperparameter tuning and optimization. Here we used a parameter tuned. First one is learning rate and batch size and number of layers and units, and next dropout rate, optimizer type, and here we used methods are grid search and random search, and early stopping and model checkpointing, and last outcome is improved generalization and reduced overfitting. Gagan.
In summary, our analysis showed the last LSTM model achieved higher accuracy and stability compared to the CNN. However, the CNN proved the be faster and better suited for a smaller dataset moving forward. Our future work will focus on leveraging the strengths of both by using a hybrid CNN LSTM model for enhanced performance in a sequence based tasks.